You ever see an electric car just glide by? It's kind of weird, right? So quiet. There's no engine roar, no puff of exhaust, just this smooth, silent whoosh. It's almost spooky, like it's running on magic or something. So let's get right into it. What's actually powering that car? And, how does electricity, something you can't even see, literally make the wheels turn? We're going to break it all down. All right, here's what we've got on tap. We'll start with what makes this tech so unique. Then we'll look at its electric heart. After that, we'll see how the power gets to the road, check out a super smart braking system, and wrap up with why this is, well, pretty much the future. At its heart, an electric car isn't just a car with a different kind of gas tank. No, it's a completely different animal. It's a total rethink of what a car even is, from the ground up. I mean, just look at this comparison. It's kind of wild when you see it side by side. A regular car is basically powered by thousands of tiny controlled explosions every minute. That's what you're hearing. That's the heat. An EV. It's all about a smooth, silent flow of electricity. And that one single difference changes everything. No noise, and this is the big one, zero stuff coming out of a tailpipe. Okay, so if there's no engine, what's in its place? What's actually doing the heavy lifting? Let's pop the hood, so to speak, and look at the electric powertrain. That's the fancy name for the system that makes it all move. It really comes down to three main players in this game, and they all have to work together perfectly. You've got the battery pack, that's the fuel tank, the inverter, think of it as the brain or the translator, and the electric motor. That's the muscle. First up, the battery pack. And yeah, it's basically the energy tank. But instead of gasoline, it's full of electricity you get from plugging it in. Every single bit of power the car uses comes from right here. But don't picture just one giant AA battery. Oh no, it's way more clever than that. It's actually made up of thousands of smaller lithium-ion cells, kind of like the ones in your laptop or phone, just way, way more powerful. They bundle these into what they call modules. And yeah, all this tech doesn't come cheap. This battery pack is easily the most expensive single part of the whole car. All right, next up is the inverter. Now, this little box has a super important job. See, the battery puts out one kind of electricity, direct current, or DC. But the motor, it needs a different kind, alternating current, or AC. So the inverter is the translator. It takes that DC from the battery and flips it into the AC that the motor understands. But wait, there's more. The inverter is not just a simple translator. It also controls the speed of the motor. How? By changing the frequency of that AC power. So when you step on the accelerator, you're not opening a fuel valve. Nope. You're sending a signal to the inverter telling it, hey, ramp up the frequency. It's the real brains of the operation. And that brings us to the muscle, the electric motor. This is where the magic really happens. It takes that AC power from the inverter and uses it to create a spinning magnetic field. And that's what creates the pure rotational force to turn the wheels. It's an amazingly simple and super efficient way to turn electricity into motion. All right, so we've met the whole crew, the battery, the inverter, and the motor. Now let's put it all together and see what happens, step by step, the moment you decide to go. So here's how it all goes down. 1, you put your foot on the accelerator. That sends a signal. 2, the battery says, okay, time to go, and sends out its DC power. 3, that power hits the inverter, which flips it to AC. 4, the motor gets that AC power and starts spinning instantly. And 5, the wheels turn. And that right there is the secret behind that instant torque everyone talks about. The second you touch the pedal, you get all the power. No waiting for an engine to rev up. It's just go. But here's where it gets really clever. The smart engineering doesn't just stop with going forward. EVs have this amazing trick for when you slow down. It's a feature called regenerative braking. In a normal car, when you hit the brakes, you're just turning your speed into wasted heat. But in an EV, the whole system runs in reverse. The wheel's momentum actually spins the motor, turning it into a mini generator. It literally recaptures energy that would otherwise be lost forever. And this comparison makes it so clear. Regular brakes, they just waste energy as heat. Regenerative brakes, they actually recover it. The motor sends power backwards through the inverter, which changes it back to DC and feeds it right into the battery. So braking or even just lifting off the accelerator actually recharges your car a little bit and boosts your range. It's just genius. So when you add all this up, the simple power, the quiet ride, that super smart braking system, you really start to get why this isn't just a minor upgrade. It's a game changer. So what's the big takeaway here? Well, it's all about efficiency. I mean, think about it. A gas engine has hundreds of moving parts, all creating friction and wasting energy. An electric motor? It might have just a handful. That means way more of the energy from the battery actually goes to the wheels to move you forward. And that's where all the good stuff comes from. That instant punch of acceleration, quieter streets, and of course, no emissions from the car itself.
It's really the whole package, isn't it? From the battery chemistry to the smart software.